So here is the part of the lab report where a lot of people lose a lot of points. The bulk of the points that I've had to take off of lab reports has definitely come from this. Okay, so your data section would come next. If you have a data table of some kind, make sure that comes first. Your data table should have a title. Your data table title should tell somebody what is being shown, even if they have no knowledge of it. So if somebody has no idea what an enzyme is, what catalase is, and your table is showing how high the bubbles went, then your title for your table should say something along the lines of uh, the, let's type this out, amount of reaction um, the amount showing the amount of reaction, the amount the differences in reaction between catalase found in blah 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 and blah measured by or in blah blah. Right. So what were your numbers? So basically, it's like almost x-axis and y-axis. What is going to be on your two axes, right? And what are you showing about those two things on your axis? So one of your axes should be your potato, your carrot, right? Your liver, your hot, your cold, your so that should all be on one axis, right? And now you're making reference to it in your title. Your other axis would be your numbers, right? What you actually measured. So your title, so it's not saying like, oh, measured in a test tube. Like that's not your numbers. That's not what you got. So don't mistake what I mean when I write this. So your data table title would take those two ideas and unify them into one title. So that anybody can read that data table title and be like, oh, okay, so it's showing me this, right? So that's number one for your data section. Number two, for your data section, you're looking for patterns in the data. Um, and in this particular instance, we're comparing room temperature to hot or cold. We're also comparing plants to animals or potatoes to carrots to liver. So you can make note of patterns here that maybe you see. Do the two plants end up looking different from the liver? Do they look different from only one of the liver? Are they similar to one of the livers? You can look at something like that, and that's something to make note of in your data section. The amount of reaction with the potato seemed to match the room temperature liver the most, right? You can make a mention of something like that. And take out the word seemed. You don't have to say seemed. You could just say the amount was closest to this. You could say all of them had the same reaction, or these ones had the least reaction, or um, something along those lines. So you're noting patterns in the data. And you're also reporting the data. You're reporting, hey, this is what happened. The potato had the highest reaction, and the livers had the lowest, right? That would be something to make note of. If it was true, that may not be the way your data came out. So you have to look at your data, and you have to be able to communicate what it says. Notice I have not answered why. If you were to ask me why, I have not answered that at all yet. That's because the why is saved for your analysis section. What does your data actually mean? If your potato was the best reaction, why would that be? Is there something the potato is exposed to in nature that leads it to needing to have more catalase than an animal or a carrot? Was it the liver? Was the boiled liver the one that was best? Why would boiling be the best temperature? What kind of conditions is liver normally exposed to? Was it the room temperature liver that did the best? Why? What kind of conditions would the liver usually be exposed to? Why would it make sense for room temperature liver to do the best, or was it frozen? So you have to explain why. I can't say what data you got. You got your data. It's in front of you. It's in your notebook. I don't have it in front of me, so I can't tell you what to say. I know what it should say, and I alluded to how you should tackle the question if your data says what it's supposed to say. I did allude to that, but I'm not picking that specific thing. So you need to narrow it down, look at your data, figure out what it is you need to explain. Okay, and you might want to look at animals versus plants. Okay, or you might want to look at potato versus carrot, or maybe carrot versus liver, or one temperature versus another. You might want to look at all those, and some of them you might be able to get an explanation for. Others you probably don't need to provide an explanation for. Um, and again, think about the conditions that those different things are exposed to normally. Why would it make sense for them to react the way they did compared to one another? Why would it make sense for carrot to react the way it did compared to liver, for instance? Okay? Are there any bodily processes that would affect what's going on here? So all that's a lot. It's a lot to unpack. That's a lot to explain. And some of it even was like alluded to in your introduction, as it should be, because these are the questions you're trying to answer. So your analysis section could be 2 paragraphs easily. Could be one long paragraph. It should not be 4 or 5 sentences. I can tell you that. A lot of people just for whatever reason seem to struggle with the analysis, and that's the biggest part. That's the meat of this. If every other section is 3 points, the analysis is like 6 or 8. The analysis is a big deal. And then you've got your conclusion. I'm just going to quickly go over that. What's something that you could put here? Was there some type of error that occurred? If there wasn't, then there wasn't. But if you think there was one, then definitely make a note of that. And why did it affect your results? Again, if there wasn't really an error and nothing really affected your results, then don't make something up. People do that. They'll make something up for the conclusion, or they'll try to make up an error. It's like, you don't have to do that. If your data doesn't seem to be affected by anything, then don't worry about it. Are there any outliers? Maybe you ran it a couple times, or maybe you noticed a group, because I know you guys have group data, I think, as well. So if there's an outlier with a group, maybe that's where an error did occur. So maybe you could mention that. Maybe one group didn't use peroxide. Maybe they used something else by accident. Like maybe there's a reason why something happened. So you look into that for your conclusion. Any further implications? Is there something you could do? Is there the efficiency of an enzyme? Could that have medical applications of some kind? Uh, or maybe technology applications? Could you develop some technology with your results? Is there perhaps another thing you'd like to test with enzymes? Is there maybe another thing you'd like to test with the specific organisms we used? Or maybe are there other organisms you'd like to take a look at? So those are all things you could propose as an alternative. So you can see there's definitely plenty you could put in the conclusion. There's still plenty of stuff that you can put in there, right? Sometimes lab reports have an abstract as well. I don't worry about that. They're important. I never had to do one in college, but they are important. But you don't have to worry about that here. So if you're looking up lab reports and you see abstracts, they are a thing. They're they're good to have, but we're not doing that for this. Okay. So hopefully that helps you. I included a lot of little nuggets between these lab report videos that I just made to help you be on the right path. And you can always ask questions when we get back to school in a few days. Wah, wah, wah. For now, this is Mr. Highwell signing off. You guys have a good day.